refer to the sheet titled Area Calculations, Sheet 1. Very basic stuff on areas. The first problem of the sheet is about a polynomial fx, whose degree we do not know, So there is a polynomial fx, and it's known to satisfy this functional equation. F of x plus 1 is fx plus 2x plus 1. And it's given that f0 is 1. We want to be able to first find the function. So let's first obtain the function fx. Since we know it's a polynomial function, very clearly fx must be like this. Fx must be, let's say we do not know the degree of the polynomial. Let's say the degree of the polynomial is n. So fx must be like a0 x power n plus a1 x power n minus 1 plus a2 x power n minus 2 plus an. That's fx. What is f of x plus 1? F of x plus 1 is like a0 x plus 1 to power n plus a1 x plus 1 to power n minus 1 plus an, right? Now let me look at the difference. What is this? This is like a f of x plus 1 minus fx equal to 2x plus 1. That means, essentially the polynomial should be such that f of x plus 1 minus fx must be a linear in x, which is a polynomial of degree 1, right? So if I take a difference, f of x plus 1 minus f of x, what does it give me? It gives me like, just look at this difference. This is like a0 x plus 1 to power n minus x power n plus a1 x plus 1 to power n minus 1 minus x power n minus 1, and so on and so forth, right? Now if I expand this binomially, what do I get? This will be like some a0. Just look at this first term. This will be like a0, and the highest x power n will get cancelled with x power n, and there is going to be nc1 x power n minus 1. That's the highest term in this difference. The highest term in this difference is going to be x power n minus 2. That means in this entire difference, fx plus 1 minus fx, the highest power of x is n minus 1. That means this difference is a polynomial of degree n minus 1. This difference, f of x plus 1 minus fx, is a polynomial of degree n minus 1. Hey, that means 2x plus 1 is a polynomial of degree n minus 1. That means, but this is a polynomial of degree 1, which clearly means that n minus 1 must be 1 and n must be 2. That means fx must be a polynomial of degree 2. Meaning what? Fx must be a quadratic in x. That means very clearly f of x must be something like ax squared plus bx plus c. Now it's given that f0 is 1. Now if f0 is 1, put x equal to 0, this turns out to be 1. 0 plus c must be 1, and this will cause c to be 1. That means fx now is ax squared plus bx plus 1, right? Now, what is f of x plus 1? F of x plus 1 is a into x plus 1 whole squared plus b into x plus 1 plus 1. That's f of x plus 1. Now if I take the difference, f of x plus 1 minus fx, and use this equation. So when I take the difference, I get like a into x plus 1 whole squared minus x squared plus b into x plus 1 minus x, and that must be equal to 2x plus 1. Right? Now this is going to give me a into 2x plus 1 plus b equal to 2x plus 1. Now this is obviously an identity, true for all values of x. So equating coefficient of x, I get 2a equal to 2 or a equal to 1. Equating the constant term, a plus b equal to 1, and a is 1, so that makes it b equal to 0. Here we have then fx completely discovered. A is 1, b is 0, c is 1. So what's fx? X squared plus 1. That's fx. Good. So we now know fx. y equal to fx is x square plus 1. Plus 1, right? Now, y, the graph of this quadratic is this is the quadratic, right? Y equal to x square plus 1, which is very clearly symmetric about the y-axis. Now what I want to do is, I want to draw from the origin two tangents to the curve. This is one tangent, say OP, and this is another tangent, OQ, from the origin, right? And this area I'm seeking the area, dotted area, between the two tangents and the curve, OP and OQ and the curve. That's the area that I'm seeking. So first of all, I need to be able to find the equation of this tangent, OP and OQ. If P is any point on this curve, that means if P has x coordinate alpha, then y coordinate is going to be alpha squared plus 1, right? Now, what's the slope of this tangent? Hey, look at this curve. The curve is y equal to x squared plus 1. The slope of the tangent at any x is given by dy dx, which is 2x is the slope of the tangent at any given x. That means the slope of this tangent is going to be 2 alpha, right? That means this must be slope equal to 2 alpha. 2x, twice x, right? Now, I can also obtain the slope from y2 minus y1 by x2 minus x1. What's the slope of OP from P and O? Alpha squared plus 1 divided by alpha. Alpha squared plus 1 minus 0 divided by alpha minus 0, and that must be 2 alpha. And that very clearly gives me alpha equal to plus minus 1. Why plus minus 1? Hey, alpha equal to plus 1 will be for P, alpha equal to minus 1 will be for Q. So very clearly I know the coordinates of P. X coordinate is 1 and y coordinate is 2. For Q, x coordinate is minus 1 and y coordinate is 2 because of symmetry. Good. Now we are almost there. So let me replace alpha by 1. P has coordinates 1, 2. Q has coordinates minus 1, 2 are the coordinates of Q, right? Now I need to, so all that I need to do is I need to find this area and double it because of symmetry. So what could be done is I could select strips of this kind. At a given x. This is my strip selection, right? What is the length of the strip? Y of the curve minus y of the tangent into dx. That's the area of the strip, right? So the area dA of the chosen strip would be y of the curve. What is y of the curve? Y of the curve is x square plus 1 minus y of the straight line. Hey, this straight line has slope. Now alpha is 1, so the equation of this line is y equal to 2x, isn't it? Alpha is 1, slope is 2, passing through the origin, so slope is 2, y equal to 2x. So y of the straight line is 2x. Y of the straight line is 2x into dx. That's the area of the shaded region. Total area would be sum of all of this, where x runs from 0 all the way to 1. X runs from 0 all the way to 1. That's the area. That's the area. Yes or no? Does it sound all right? So what does this turn out to be? This turns out to be integral x minus 1 whole square dx, 0 to 1, which is like x minus 1 whole cube by 3, 0 to 1, right? So at x equal to 1, 0, at x equal to 0, minus 2, so this is 1/3, that's 1/3, right? So this area is 1/3, this is also 1/3, so the required area is going to be 2/3. The required area is going to be 2/3. That's what we are seeing. Pretty simple, isn't it? So area calculations is easy and pretty much within reach. Get a hang of how to select your strips. Let's look into the next few problems of the sheet. All right, bye-bye. Which has caused you some internal commotion. So this is the graph of y equal to sine x squared, say. And there is a point P whose x coordinate is t and whose y coordinate is t squared. And this is area designated by A, a function of t. Right? And this point P is just mapped in the xy plane. The coordinates of this point, just in a separate xy plane, I write this point P, x comma y, and I constitute a triangle out of this. The area of this triangle I refer to as BT. And I need to find limit t tending to 0 AT by BT. Hey, look at this. Limit t tending to 0. What is AT? AT, realize, is this area y, which is sine x squared dx. X runs from 0 to t. Would you want to believe this? That's AT. Y dx, taking vertical strips, y dx. Right, that's AT divided by BT. BT is the area of this triangle, half base into altitude, half of t into sine t squared. Half of t into sine t squared. Yes or no? I need to obtain this limit. Any idea how we could obtain this limit? Yes, I'll have to apply, because I need to dispense away the integral sign. The only way I can dispense away the integral sign is by differentiating. Leibniz. So I'll have to obviously apply L'Hopital's rule. I need to differentiate both numerator, denominator. It's of the form 0 by 0. Do you see that? Because at t equal to 0, this is 0 to 0, 0. This is 0 by 0. So I'm eligible to do that, right? Also, first level of simplification, I get rid of this. I do a t squared here. This will become a t cubed. And limit as t tends to 0, this anyways will become 1. This anyways will become 1. So I get rid of it right here. I get rid of it right here. Right? And allow this 2 to go up there. Right? Now, this is limit. Twice limit. When I differentiate this, what do I get? Sine t squared is what I get. When I differentiate this, I get 3t squared. St tends to 0. Hey, sine t squared by t squared, St tends to 0 is 1. So this is going to be 2/3. 2/3. Yes or no? Got me? Let's look at the third problem of this problem sheet. What's given is a curve y equal to x power n, and it's given that n is greater than 1. And now there is a point P on the curve, 1 comma 1, as you can see, is indeed a point on the curve. A tangent is drawn at the point P of the curve. A tangent is drawn at the point P of the curve. Now, between the tangent, the curve, and the x-axis, you see this dotted area. You see this dotted area. Yes or no? What we want to do is, we want to maximize this dotted area by varying n. That means, we want to make a selection on n larger than 1, we want to make a selection on n larger than 1 such that this area A is maximized. Yes or no? Right? Now, first things first. Let me find the equation of this tangent. This tangent passes through 1 comma 1. It's a tangent to the curve y equal to x power n. Now, can I find the equation of this tangent? Yes. What's the slope of the tangent? The slope of the tangent is given by dy dx at x equal to 1. Right? This is x equal to 1. What's dy dx? That's nx power n minus 1 at x equal to 1. That makes it n. That's the slope of the tangent n. Right? N I have to model larger than 1 so that this area is maximized. So I want to write this area in terms of n and then maximize that area by choosing an appropriate value of n. Now, how do I find this area A? What I do is I select horizontal strips of this kind between the tangent and the curve, between the tangent and the curve. Yes or no? So very clearly these strips are of vertical width dy and the length of each of these strips is x of the tangent here minus x of the curve. X of the tangent minus x of the curve. Now what's the equation of the tangent? The equation of the tangent, as you can see, is the tangent passing through 1 comma 1 and the slope is n, as we've discovered. So y minus 1 is n into x minus 1. So any x on the straight line, that is the tangent, is given by y minus 1 by n. Y minus 1 by n. So y on the tangent, x on the tangent minus x of the curve. What's x of the curve? X of the curve is y to power 1 by n. So x of the tangent is y minus 1 by n plus 1, as you can see, minus x of any point on the curve, this point on the curve, which is y to power 1 by n. That's the area of this chosen strip, right? That's the area of this chosen strip. What we want to do is, we want to find the summation of all of this. We want to find the summation of all of this, where y runs from 0 to 1. Y runs from 0 to 1, right? So all that I need to do here is, I need to integrate this. That will give me the required area, where y runs from 0 to 1. Y runs from 0 to 1. That's what we need to be able to do. Good. So after we integrate this, we will get area as a function of n. So area as a function of n then turns out to be, so when I integrate y minus 1 with respect to y, I get y minus 1 whole squared by 2n, right? So this is going to give me y minus 1 whole squared by 2n, where y runs from 0 to 1, supplying the limits, and then plus 1, 0 to 1, that will give me 1 minus y to power 1 by n plus 1 divided by 1 by n plus 1. Y runs from 0 to 1, right? That's what happens. So let's obtain it in terms of n. What does it turn out to be? When y is 1, it's 0. When y is 0, it's 1. So this will become minus 1 by 2n plus 1. And this is going to become, at y equal to 1, 1 minus 0. So that's like a n by n plus 1. That's area as a function of n. Area as a function of n, which is, so now, what I'll do is, I want to maximize A. I want to maximize A, keeping in mind that n has to be larger than 1. I need to select a suitable value of n that will maximize the area A. So let me find the interval of monotonicity of A. Intervals, let's say, in which area is increasing. That will give me an idea to what extent A would increase, right? So A dashed n, what's that? That's like a 1 by 2n squared. This will be 0 minus derivative of numerator 1 into n plus 1 minus n divided by n plus 1 whole square, right? So that makes it 1 by 2n minus 1 by n plus 1 whole square, right? Right? Let me find out intervals of n in which A is going to increase. That means A dash 10 positive. Let me find out the interval in which A dash 10 is positive. So what does that give me? That gives me, like, if this is positive, I end up getting n plus 1 whole squared minus, this is 2n squared minus 2n squared is greater than 0. That's what I get out of this. N plus 1 whole squared minus 2n squared greater than 0. This in turn will give me like a n squared minus 2n minus 1 less than 0, right? This in turn could be written as, if I factorize this, n minus 1 whole squared minus 2. N minus 1 whole squared minus 2. Do you realize why I did that? I want to express this. So minus root 2 whole squared less than 0, right? Which in turn leaves us with n minus 1 plus root 2 into n minus 1 minus root 2 less than 0, right? That's what I get, right? Now, n is given to be greater than 1. N greater than 1 means n minus 1 is positive, root 2 is positive. That means this factor is a positive factor. This factor is a positive factor. So if this is positive, the product is negative. That means this must be negative. So n minus 1 minus root 2 must be negative. So n minus 1 minus root 2 less than 0. That gives me n less than 1 plus root 2. N less than 1 plus root 2, which means what? Area increases up to n equal to 1 plus root 2. A dash 10 positive for n less than 1 plus root 2. That means up to 1 plus root 2 area is increasing. That means after 1 plus root 2 the area must be decreasing. That's area symbolically represented, increasing up to n equal to 1 plus root 2 and subsequently decreasing. Which means n equal to 1 plus root 2 must be giving me the maximum area. N equal to 1 plus root 2 must be giving me the maximum area. So here we have the value of n that will maximize the area. Value of n that's going to maximize the area. Yes or no? Right? We needed to find n that will maximize this area. It's a fairly simple problem, just that it involved a few things, combination of things, but pretty much within reach. The choice of strip was very critical here. The choice of horizontal strips made area computation easier, right? Thank you so much. Bye-bye. Next problem of the sheet is about two curves. See this one, y equal to fx, the outer one. And this one is y equal to sine x, y equal to sine x. This is sine x, right? And the two curves intersect at 3 points, A, B and C. B and C are pi and 2 pi, and A has x coordinate A, and this is f of A, right? It's given that A1, which is this area, A1, which is this area, is given to be 1 minus sine A plus A minus 1 cos A. So first things first, I need to be able to find fx. Having found fx, then I need to find small a, and I want to find A1. These are things that I want. And then A2 and A3. So this area, this strip, what is this strip equal to? Can you tell me? Sin x minus fx is the strip. Sin x minus fx. So sin x minus fx dx is the chosen strip. Sum of all of this, where x runs from 0 to a, 0 to a, and that's equal to a1. That's equal to a1, which is 1 minus sine a plus a minus 1 cos a, right? Cos a. I want to find fx first. I'm going to apply Leibniz, right? Very good, very good. I'm going to apply Leibniz. So if I apply Leibniz, if I differentiate this with respect to A, I'm going to differentiate with respect to A. For a moment, I'll imagine A to be a parameter, right? Let me differentiate this with respect to A. I get sine A minus FA. Sine A minus FA is what I get when I differentiate with respect to A, equal to minus cos A, right? Plus cos A plus A minus 1 into minus sine A. This is what I get, right? What happens? Sine A cos A will get cancelled with cos A, and then sine A will get cancelled with sine A, leading to FA equal to A. Yes or no? Right? Which means now I generalize. I say fx then must be x sine x. X sine x. Next. A, B, C are points where fx and sin x become equal, right? A, B, C are points where the two graphs intersect. That means fx becomes equal to x sin x. Fx becomes equal to sin x, right? The two become equal. But what is fx? X sin x is sin x. Now, this can happen either when sin x is 0. When is sin x 0? Sin x is 0 at B and C. So this is about the points B and C, right? But when sin x is not 0, then when sin x is not 0, then x must be 1. And this must be about the point A. This must be about the point A, right? So for this specific point, A then turns out to be 1. A then turns out to be 1, right? Yes or no? Huh? Confusion? No? Now, of course, once you know A, you know fx. Fx you can write as x sin x, right? That's A1. A you can replace by 1. You know how to integrate this. You know how to integrate this. You want to integrate this using by parts, right? Using by parts. You can find A1. Similarly, what's A2? A2 is this shaded region. What is A2? A2 is going to be given by integral fx minus sin x dx, where x runs from 1 to pi. X runs from 1 to pi. 1 to pi. Okay, fx is x sin x. You can integrate this. Then what is A3? Okay. There is sin x minus fx. Why? Because see, sin x is less negative than fx. So sin x minus fx will be a positive number, right? Dx, x runs from pi to 2 pi. That's A3. That's normal integration. Fx replaced by x sin x, and you can obtain all of this. Stand by. Next problem is about these two curves, y equal to 1 by x squared and y equal to 1 by 4 into x minus 1. And the A is a number greater than 2. A is a number greater than 2. The area between these two curves from x equal to 2 to x equal to A is 1 by A. That's given. The area between the two curves from x equal to 2 to x equal to A is 1 by A. Read the problem. I'm only simplifying the statement of the problem. Right? It's given to be 1 by A. And what is it that we want to find? A. We want to be able to find the value of A. First things first. Let's draw the two curves. Y equal to 1 by x squared and y equal to 1 by 4 into x minus 1. Let's first draw the two curves. So y separately first and then we'll merge them. Y equal to 1 by x squared. Realize y can never be negative here. Y can never be negative here. Also, as x tends to 0, y tends to plus infinity. And as x tends to infinity, y tends to 0. As x tends to infinity, y tends to 0. Yes or no? Also, do you realize that the dy dx is minus 2 by x cubed? And therefore, in the first quadrant, it's negative. That means it's monotonically decreasing for x greater than 0. Right? Because dy dx is negative in the first quadrant. Yes or no? That's not it. When you see only even powers of x featuring here. That means if x comma y lies on this, if x comma y lies on this curve, then minus x comma y will also lie on this curve. Yes or no? And x comma y, if this is x comma y, minus x comma y will be its mirror image about the y-axis. That means the curve enjoys symmetry about the y-axis. If there are only even powers of x appearing in an equation, then the curve has to be symmetric about the y-axis. If there are even powers of y, then it has to be symmetric about the x-axis. So for sure, if this is the curve in the first quadrant, then this is how it is in the second quadrant, enjoying symmetry. That's y equal to 1 by x squared. What do you say? Then next, y equal to 1 by 4 into x minus 1. Do you realize as x tends to 1 from the greater than 1 side, y tends to plus infinity? As x tends to 1 from the greater than 1 side, y tends to plus infinity. X equal to 1 is a vertical asymptote, right? This is x equal to 1, a vertical asymptote. As x tends to plus 1 from the greater than 1 side, y tends to plus infinity. That's evident, right? Also, as x tends to 1 from the less than 1 side, this is going to be a negative number. Y will tend to minus infinity, yes or no? So that means down below it's like this, it must be something like this, right? Yes or no? Also, what is dy dx? Dy dx for this is minus 1 by 4 into x minus 1 whole square. Always negative. That means it's forever decreasing. Also, as x tends to infinity, y tends plus or minus infinity, y tends to 0. Good. All these facts put together. And it has no turning point. It's decreasing throughout. As x tends to plus infinity, it is 0. Starting heavenwards, right? And then at x equal to 0, it's a negative number, so goes this way. As x tends to minus infinity, also it's going to be 0. It's forever decreasing. Do you realize? It's forever decreasing. Yes or no? That's the graph of y equal to 1 by 4 into x minus 1. Good for us. I want to find the area between the two curves. We'll merge the two curves together, but for the time being, let's first find the point of intersection of the two curves. Do you all understand how we sketched the graph of the two curves, right? Good. Now, when are they equal? They are equal. That means their point of intersection. When they're for a given x, they have the same y, then, right? To obtain x, the point of intersection of the two curves. This will give me x coordinate of the point of intersection of the two curves, right? So x squared minus 4x plus 4 is 0. X minus 2 whole squared is 0. X is 2 comma 2. Hey, x is 2 comma 2. They intersect at two coincident points. There is more message than this. These two curves are intersecting at two coincident points. What does it mean? Hey, let's say when this is one curve, do you realize this is intersection at two coincident points? That means they must be touching each other at two. They must be touching each other at 2, yes or no? That means at x equal to 2, they must be having a tangent of the same slope. That means at x equal to 2, their dy dx must be the same. At x equal to 2, their dy dx must be the same. Let's check that out. What is the dy dx for 1? Minus 2 by x cube. At x equal to 2, minus 1 by 4 for one curve, right? Dy dx. Slope of the tangent for one curve at x equal to 2, right? For the other one, minus 1 by 4 into x minus 1 whole square. At x equal to 2, it's minus 1 by 4. Do you realize? At x equal to 2, they have a tangent of the same slope. That means they should have been touching each other at x equal to 2. Right now? Right? So now, we are all set. Let's put that. So 1, the two curves touch each other at x equal to 2. Right? And can I just remove that calculation and draw both the graphs on a common frame? X equal to 1. At x equal to 1, this is 1. At x equal to 1, this is 1, but this is infinity. That means at x equal to 1, this is much higher than this. Right? So this is the line x equal to 1. This graph has a point P here. And it is decreasing. Right? This is y equal to 1 by x squared. This is the point P, 1 comma 1 on y equal to 1 by x squared. What do you say? The other graph starts from here, right? This other one, y equal to 1 by 4x minus 1. Starts from here, it does this, it touches and stays up. It is not going to cut, it's not going to fall through the other graph. It goes this way. Let me draw a superior view of this. This is how it is. This is the other graph. At x equal to 2, they touch each other, yes or no? You know what I'm saying? This is the look. Confusion hai? Nahi na? Good. So this is x equal to 2. This is y equal to 1 by 4 into x minus 1. And this is y equal to 1 by x squared, right? This one. This is x equal to a. This is x equal to a. Now, what is this strip? This strip is upar wala graph 1 by 4x minus 1 minus 1 by x squared. Right? This strip, Chutku strip. Right? This is 1 by 4 into x minus 1 minus 1 by x squared is this chosen strip. That into dx is the area of the chosen strip. The area, this is the area that we are seeking between the two graphs. From x equal to 2 to x equal to a. A is greater than 2, that's given. So a will be to the right of 2. So this dx, sum of all of this, starting from x equal to 2 to x equal to a, and that must be equal to 1 by a. That's merely the statement of the problem. That's merely the statement of the problem, right? I want to now solve for a. I now want to be able to solve for a. But so far so good, right? Everything in place. So this is 1 by 4 log x minus 1. So log a minus 1 at x equal to log x 2 minus 1 log 1 0. Say at x equal to 2 this will be 0. Then this will be plus 1 by x. 1 by x means 1 by a minus 1 by 2, right? 1 by, this will be plus 1 by x. So 1 by a minus 1 by 2, that's equal to 1 by a, right hand side. 1 by a, good for us, gets cancelled. Log a minus 1 half, so 2. A then is 1 plus e squared. A then is 1 plus e squared. A minus 1 is e squared. A minus 1 is e squared. A then would be 1 plus e squared. That's the way it goes. Got me? Problem, y equal to fx equal to ln x minus c by x. Let's first draw the graph of this curve. Let's draw the graph of this curve. Few basic things. Do you realize it has a root? That means root means point where y becomes 0. That means ln x becomes c. That means x equal to e power c. Yes or no? X equal to e power c is a root. Also notice that as x tends to 0, obviously greater than 0 side, because x less than 0 does not belong to the domain of this function. As x tends to 0 from the greater than 0 side, y tends to minus infinity, because ln x will tend to minus infinity and this will produce plus infinity minus, so y tends to minus infinity. Yes or no? Bolo. No? What is y? Y is ln x. Then how did you draw the graph? So, as x tends to 0 from the greater than 0 side, what happens to ln x? Ln x tends to minus infinity. Yes or no? This, so numerator tends to minus infinity, denominator tends to 0, so y tends to minus infinity, right? So y tends to minus infinity. Let's draw the graph in pieces. As x tends to 0, y tends to minus infinity. At x equal to e power c, we will see a root, x equal to e power c. Okay. Now, as x tends to plus infinity, what happens to y as x tends to plus infinity? What is limit ln x minus c by x as x tends to plus infinity? Numerator also tends to infinity, denominator also tends to infinity, but I have told you that a polynomial will increase faster than a logarithm. So this will tend to 0 because numerator tends to infinity, denominator also tends to infinity, but the denominator tends to infinity faster than the numerator. Yes or no? So this is 0. Right? That means as x tends to infinity, y tends to 0. Y tends to 0. At x equal to e power c is a root. There is only one turning point. There is only one turning point. And you would therefore expect the graph to look something like this. Right? I'm assuming there is only one turning point, but I'll have to check. This is x is e power c, which is a root. And I want to find the turning point, which must be a local maximum only, right? So let's find dy dx. 1 by x into x1 minus ln x by x squared. Is it? No, ln x minus c. Right. That's the derivative, right? That's the derivative of this is 1 by x into x, which is 1, minus derivative of denominator, which is 1, into ln x minus c. Yes or no? Which is 1 plus c minus ln x by x squared. This becomes 0, dy dx is 0 at x equal to e power 1 plus c. Yes or no? At x equal to e power 1 plus c, that means this point must be e power 1 plus c. Right? Now, what area are they seeking? They're seeking, this is the point of maximum at x equal to e power 1 plus c, and the vertical line through the maximum point, this is the vertical line through the maximum point, area bounded by the curve, the x-axis, and this curve, x-axis, and this. So what area? This is the area, isn't it? This is the area that is being sought, right? And we want to show that it's independent of C, right? So what kind of strips are we going to select here? We're going to select strips of this kind, vertical, y dx, where x runs from e power c to e power 1 plus c, right? This strip is y dx. Y is what? Y is ln x minus c by x dx. X runs from e power c to e power 1 plus c. That's the area, and we want to show that this is independent of c. We can integrate this, right? We can integrate this. How do I integrate this? I can, do you realize this is d of ln x minus c? Yes or no? This is d of ln x minus c. T dt, t square by 2. T dt, t square by 2. So this is ln x minus c whole squared by 2, where x runs from e power c to e power 1 plus c. Right? Yes or no? Do you all understand what I did here? Which then means so I want to show that this number is independent of c. That means I want to show that the numerator is independent of c, right? Okay, nevertheless, this is half of, at x equal to 1 plus c, this will become 1 plus c. At x equal to e power 1 plus c, this will become 1 plus c. 1 plus c minus c, that's 1. That's 1 minus, at x equal to c, e power c, this will become 0. So half, which is independent of c. Yes or no? Which is independent of c. Could I have done it without integration also? Yes, check that out. Treat c as a parameter, and if you can show that dA dC is 0, then A should be independent of c. You know what I'm saying? Treat c as a parameter, find dA dC, and if dA dC turns out to be 0, then A must be independent of c, isn't it? That's when dA dC will be 0. That's another way you can check. But in this case, since the integration was so easy, we didn't bother too much about that. Turns out to be half, which is independent of c. Got me? Stand by. Able to trace the graph of this first, and want to find the area that this curve and its asymptotes include. This drawing the graph of this function would be tremendously instructional. So therefore, listen to me very intently. Now, would you not want to believe? Since this is non-negative, this has to be non-negative, right? That means 1 minus y into y is greater than or equal to 0. That's the only way this can be a non-negative number, right? Which means for any xy on the curve that lies on this curve, for any xy that lies on the curve, this would mean what? Y greater than or equal to 0, less than or equal to 1. From wavy curve, y greater than or equal to 0 but less than or equal to 1. Y must lie between 0 and 1, yes or no, right? So this is the range of this function. The function will lie between 0 and 1. First things first, yes or no? Bolo? Confused? Do you understand this greater than 0? Nahin? X square greater than or equal to 0? The product is positive, so this has to be greater than or equal to 0, right? So then, if this is greater than or equal to 0, y must lie between 0 and 1, no? Because see, if y was greater than 1, this will become negative, this is positive. Or y less than 0, this will be negative, this will be positive. Right? So y must lie between 0 and 1. That means y is the range of this function, right? Range of this function, y is a function of x here. So the function must lie strictly between 0, not strictly, it assumes a value 0 as well, right? So it must lie between 0 and 1. That's guaranteed. So first things first, let's do a convenient plot here. This is the line y equal to 1. This is the line, x-axis is y equal to 0. I'm assured that the graph, the plot of this lies between 0 and 1. That's guaranteed. Right? Now, the other thing is, it's only even powers of x. Right? What would that mean? Symmetric about the y-axis. It would mean the curve is symmetric about the y-axis. Right now? So many m's. Y-axis. Cool? The curve is symmetric about the y-axis. Huh? Also, look at this. X square is 1 by y into 1 minus y. Do you realize as y tends to 0, x tends to plus minus infinity? As y tends to 1, x tends to plus minus infinity? Yes or no? Right? Which means as y tends to 1, it tends to infinity. As y tends to 0, x tends to plus infinity. One of the values, and then of course out. So I know I'll half cook the whole thing, and then so it must look something like this, converging this way, right? Yes or no? Now, okay. Now look at this. Can I just remove the clutter from here? How would you want to take this? What does that mean? Gm less than or equal to am. And why could I apply that? Because see, y and 1 minus y are both non-negative. Right now, that's why Gm less than or equal to am. Yes or no? Right? That means this is less than or equal to half. That means 1 minus y into y will always be less than or equal to 1/4. Right? Now look at this. So this would also mean 1 by y into 1 minus y will be greater than or equal to 4. But what is this? This is x square. This is x square, yes or no? That means x square greater than or equal to 4. That means mod x greater than or equal to 2 for any xy on the curve. Yes or no? Which means mod x greater than or equal to 2 means either the curve lies to the right of 2 or it lies to the left of minus 2. No part of the curve will lie between minus 2 to plus 2. Yes or no? Nice. This is x equal to 2. This is x equal to minus 2. The graph will lie either to the right of 2 or to the left of minus 2. Hey, one thing, if it is lying to the right of 2 and I am already guaranteed that it's symmetric about the y-axis, then it must lie to the left of minus 2 owing to those symmetry considerations. So that didn't spring a surprise anyways, right? So no part of the curve, this is prohibitive region for the curve. No part of the curve will belong to this region. It will lie to the right. And once I am able to draw this part, then I can map it here directly, right? Huh? Good. Now, can I remove this part? What is x squared? X squared is 1 by y into 1 minus y. Or what I could do is say, I need not do this. This is x squared into y minus y squared is 1. And then let me differentiate with respect to y throughout. So 2x dx dy, 2x dx dy, right, into y minus y squared plus x squared into 1 minus 2y is 0 when I differentiate with respect to y, right? Bolo. Now, do you realize again, if x is 2, 4, 1 by 4, y is half, x is 2, y is half. Do you see that? That means 2 comma half is a point on the graph of the function. This is a point. X is 2, y is half. 2 comma half is indeed a point on the graph of the function. Yes or no? At y equal to 2, y equal to half. At y equal to half, do you realize this will become 0? At y equal to half, this will become 0, right? 1 minus 2y will become 0 at y equal to half. I'm trying to find dx dy at y equal to half. I'm trying to find dx dy at y equal to half. Dx dy at y equal to half will become 0, yes or no? Right? Right? Dx dy at y equal to half is 0. Dx dy means what? That no, dx dy becoming 0 at x equal to half at y equal to half means dy dx is infinity at that point. That means at x equal to half there is a vertical tangent because dy dx is infinity. That means this becomes a tangent at x equal to 2 and y equal to half. Slope of the tangent will become infinity, right? So this becomes my tangent at x equal to 2 or y equal to half, which means now I would expect the graph to be something like this. This is not the end of the story. So far so good, right? And of course on this side, I'm expecting it to be something like this on this side. This would be minus 2 comma half would be this point, say q, right? This is the line y equal to half. And I claim for this part y equal to half is a line of symmetry. Why? I claim that this is a line of symmetry. See, x squared turns out to be 1 by y into 1 minus y. This is a quadratic now. Every quadratic, say at squared plus bt plus c. Every quadratic has a line of symmetry that is obtained by differentiating this with respect to t and equating to 0. I'll get t equal to minus b by 2a as my line of symmetry. So y into 1 minus y d dy d dy of y into 1 minus y. What is, when does this become equal to 0? At y equal to half. See, what is this? 1 minus 2y is 0. That means at y equal to half must be the line of symmetry for 1 by y into 1 minus y, right? So y equal to half is a line of symmetry for this graph. The way it looks above y equal to half is the way it looks below y equal to half. Yes or no? So same thing here. This is the graph. Now, what are the two asymptotes? There are horizontal asymptotes, this asymptote and this asymptote, right? And we are seeking, let me call this point P 2 comma half, right? What we are seeking is, say, area, this kind of aerial strips. This kind of aerial strips. See, this is the area that I am seeking between the asymptotes. This is the area between the graph of the function and the asymptotes. This is the area that we are seeking. So that means these must be my strips. I must sum up these strips starting from y equal to 0 to y equal to 1. I must sum up these strips. Yes or no? This is what I need to do. Are you all there with me? So, what I'll do is, I'll just take this and double it because it's symmetric on this side, right? So, if this is x, this thickness is dy, right? So, what's this area of this strip? X dy? X dy is the area of the strip. So, x dy is the area of the strip. And I need to sum up starting from y equal to 0 to y equal to 1. That's to the right of the y-axis, but the same thing to the left of the y-axis. This is what I need to do. This is my required area. X I can write as 1 by root y into 1 minus y. See, x is what? 1 by root y into 1 minus y, right? So, because my subject of integration is y, so I need to write everything in terms of y. So, this then is what? Twice 1 by root y into 1 minus y dy. Y runs from 0 to 1. This will be, how do I integrate this? How do I integrate this? One, of course, square root of quadratic, right? Otherwise, okay, y equal to sine square theta, say. So this is the integration to be handled, 0 to 1 dy by root y into 1 minus y. I can take y equal to sine square theta, say. So, when y is 0, theta is 0. When y is 1, theta is pi by 2. Theta becomes my new subject of integration, right now? So, this would be twice, dy would be 2 sine theta cos theta d theta, right? Dy would be 2 sine theta cos theta d theta. And this will become sine theta cos theta. Theta runs from 0 to pi by 2. Yes or no? Right now? So very clearly this gets cancelled. So that makes it 2 pi. That's the required area. 2 pi. Sounds good?